In this lesson, we will define entropy and learn how to predict whether entropy is increasing or decreasing in a reaction. As a reminder, endothermic reactions have an enthalpy greater than 0, and we see that heat is transferred from the surroundings into the system. For an exothermic reaction, the change in enthalpy is less than 0, and we see heat exiting the system. Entropy is another thermodynamic property that gives us a way of measuring the disorder in a system. We can also think about this as the number of ways to arrange something. Looking at the two boxes on the bottom, we see that they both contain 9 butterflies. On the left, we see a very ordered and systematic arrangement of the butterflies. On the right, we see that the butterflies are all in different directions and are spread throughout the container. The system on the right has a greater entropy than the system on the left. Another place where we see entropy changes are with phase changes. As we go from a solid to a liquid to a gas, we see an increase in the entropy. Remember that delta always means final minus initial, so in going from a liquid to a gas, the entropy of the gas is greater than the entropy of the liquid. So we will see that delta S, or the change in entropy, will be greater than 0. Going from a gas to a liquid to a solid will be a decrease in entropy. There are several characteristics of a system or a reaction that we can look for to determine if the entropy increases, which would result in a positive delta S value. Going from a solid to a liquid to a gas will be an increase in entropy. Increasing the temperature is an increase in entropy, because as we increase the temperature, we increase the speed of the molecules, and so we see that they're moving more and are arranged in more ways, so more disordered. If we have more particles, there are more ways that those particles can be arranged, so that would lead to an entropy increase. An increasing number of gas molecules, because gases have higher entropy than liquids or solids. And we will also see an increase in entropy when a solute dissolves in a solution, because there are more ways for those ions or particles to be arranged in the solution than as a solid. Let's look at some examples where we can predict whether the entropy will increase or decrease for each reaction. For number 1, calcium carbonate solid forms CaO solid and CO2 gas. Because we're forming CO2 gas and we don't have any gaseous reactants, this will be an increase in the entropy. For number 2, we have N2 gas plus H2 gas to form ammonia gas. Notice that we have 4 moles of gas on one side and 2 moles of gas on the other side. So we will see a decrease in the entropy. For number 3, we have sucrose as a solid and then sucrose dissolved in water. Because we're going from a solid to an aqueous solution, this will be an increase in entropy. For number 4, we have solid copper at 25 degrees Celsius going to solid copper at 100 degrees Celsius. As we change temperature from 25 degrees Celsius to 100 degrees Celsius, we will see this as an increase in entropy. For number 5, we have water in the gas phase going to water in the liquid phase. As we go from gas to liquid, we will always see a decrease in entropy.